4.1, complex numbers. If we try to solve quadratic equation of this kind, x squared plus 1 equals 0, x squared equals -1, and we know there is no real number whose squared is -1, so the solution is not real here. Solution is not a real number. So we normally say it doesn't have a solution. However, if we introduce an imaginary unit, I, such that the square of this unit is exactly -1. So that's how we create this unit. So the square is -1. So this quadratic equation will have a solution then. Another way to imagine those imaginary numbers will be to plot them on the plane. So we have the number line, the real number line here. These are the real numbers, so I have 0, 1, 2, and here the negative numbers, and all the rational numbers, the fractions, the irrational numbers. Pi is here, somewhere here. These are all the real numbers. So I imaginary unit, it's nowhere here on this line. It's somewhere else. So we're going to draw another vertical axis. We'll call it the imaginary axis. And this is similar to the x and y coordinate system, but it's not the same thing. So on this axis, we're going to mark I, since it's a unit, to be 1 unit above, and this is 2i, and 3i, 4i, and so on. Underneath here, -i, -2i, -3i, and so on. So all the imaginary numbers, we call them pure imaginary numbers. They're going to be on the red line. Pure imaginary numbers. So they are I, 2i, 3i, and so on. Now, if we combine a real number, let's say 2, with an imaginary number 3i, so this number over here, we'll call it 2 plus 3i, complex number. So if we combine real numbers with pure imaginary units, we get complex numbers. So a complex number would have a form a plus bi, where a is the real part and b is the imaginary part. So a comes from the real axis and b comes from the imaginary axis. So we call this standard form. Standard form a plus bi. So later on, we're gonna introduce a different form, a trig form of a complex number, but this is the standard form. Now let's talk about operations of complex numbers. That is addition. So if I have a number a plus bi and another complex number c plus di, we add them by adding the real parts, a plus c, and we add the imaginary part, b plus d. And so the result is a complex number. In a similar way, we subtract complex numbers, a plus bi minus c plus di, by subtracting the corresponding real parts and corresponding imaginary parts. Example, 4 plus 7i plus 1 minus 6i. These are two complex numbers. So to add them, we add the real parts. So that's 4 plus 1, and that's 5. And then we combine the imaginary parts. So 7 minus 6i would be just I, so 4 plus I. So let's call this part A, part B, 1 plus 2i minus 4 plus 2i. You have to be careful with the subtraction because we can't just ignore the parentheses. So what I would do is write the first complex numbers the way it is without the parentheses, then distribute. So minus 4 minus 2i, and then combine like terms. So 1 minus 4 is negative 3, and 2i minus 2i cancel. So you just get negative 3. So we got a real number, which is also a complex number because, as you can see here, the real numbers are part of the plane. So all these numbers here on the plane are called complex numbers. That includes the real numbers and the pure imaginary numbers. So part C, 3i, which is pure imaginary number, minus negative 2 plus 3i. We're going to distribute. That becomes plus 2 minus 3i, cancel. And what's left is just 2. We got a real number again. Now, how do we multiply a number, a real number, by a complex number? For example, 4 times negative 2 plus 3i. We just distribute, multiply 4 by the real part, negative 8, multiply by imaginary part, plus 12i, and that's it. The result is a complex number. Another example, multiply 2 complex numbers. We don't have a formula per se, we just multiply as we FOIL. We treat I as its x, and so if you FOIL, you do 2 times 4, 8, and then 2 times 3i plus 6i, and then minus 4i minus 3i squared. Then we combine like terms, so it's 8 plus 2i, and what is I squared? This is how we introduced I, by setting the square of I to be negative 1. So this is very important formula. I squared is negative 1, and another way to write this down would be that I is square root of negative 1. That's equivalent. So back here, when we had I squared, that I squared is equal to negative 1. And we get plus 3, because negative 3i squared will be negative 3 times negative 1, so that is plus 3. Combine like terms, and you have 11 plus 2i. So that's how we multiply a complex number, by foiling them. 3 plus 2i squared. What it means to square a complex number, it means to multiply it by itself. And we already know how to do that. You FOIL or use the special formula that is a special trinomial. So 9 plus 6i plus 6i plus 4i squared. Combine like terms, so it'll be 9 plus 12i minus 4, because I squared was negative 1, and 9 minus 4 is 5 plus 12i. So the result, again, is a complex number. So far we have addition, subtraction, multiplication, and before we do division, we need to introduce a concept called complex conjugates. Complex numbers don't have opposite because they're all over the plane, but they have conjugates. So a plus bi and a minus bi are called complex conjugates. Okay, if you think about where they are on the plane, they are symmetrical with respect to the real number line. So for example, where is the conjugate of this? That would be 2 minus 3i. 2 minus 3i is a conjugate of 2 plus 3i. So what happens when you multiply two conjugates? Let's try. A plus bi times a minus bi, and we FOIL. This is a special product actually. So a squared we can just say minus bi squared. If you use the formula a plus b, a minus b, or if you FOIL, the two terms in the middle will cancel. So that is a squared. And then minus b squared, I squared, but I squared was -1. So that is I squared plus b squared. So what happens is there's no I. When we multiply two conjugates, the result is a real number. So that's very important. When you want to get rid of a I or complex number, you multiply by the conjugate. So let's try it with specific pair, 1 plus I, 1 minus I. So that will be 1 minus I squared. But I squared is -1, so become 1 plus 1, which is 2. So indeed, we're getting real numbers. 4 minus 3i times the conjugate, 4 plus 3i. So that is 16 minus 3i squared, which is 16 plus 9. If you want to do it slowly, we can do slowly. So minus 9i squared, so that is 16 plus 9, which is 25. So now we're ready to introduce dividing complex numbers. So we're going to write 2 plus 3i divide by 4 minus 2i. These are two numbers, we want to divide them. I'm writing them as a ratio or a fraction. We know fraction bar means division. So first thing we're going to do, let me copy the problem, and we're going to multiply by the conjugate of the denominator. So the conjugate of the denominator is 4 plus 2i, and we need to multiply that both the top and the bottom. So nothing changes. So we have to FOIL quite a bit here, and on top we have 8 minus 4i plus 12i minus 6i squared. On the bottom will be easy because they're special. Their conjugates will be 16 minus 2i squared. So that is equal to, combine like terms, 8 plus 8i plus 6, because I squared was -1. And here we're going to have 16 plus 4, because I squared is -1. So finally, we have 14 plus 8i all over 20. So let's check our work, make sure we got this right. 2 plus 3i over 4 minus 2i, multiplied by the conjugate, 4 plus 2i, and FOIL. So that will be 8 minus 4i plus 12i minus 6i squared. So that's 8, 12 minus 4 is plus 8i, and then plus 6. So that is 14 plus 8i over 20. So divide each one separately. 14 over 20 plus 8i over 20 equals, I can divide by 2, 7/10, plus I can divide by 4 here, 4/5 I. All right. Let me make a note here. So I squared is -1, so that becomes plus 6. Okay. Another example is 5 plus I divided by 5 minus I. I'm going to copy this again and then multiply by the conjugate of the denominator, which is 5 plus I. Oh, I see, yes. Okay, 5 plus I. So now we are foiling on top. This is special product, so 25 plus 5i plus 5i plus I squared, and on the bottom is special, a plus b, a minus b, so 25 minus I squared. So that's equal to 25, and then plus 10i minus 1 over 25 plus 1. So 25 minus 1 is 24 plus 10i over 26. So you want to write your final answer as a complex number in a standard form. That means separate real and imaginary part. So 24 over 26 plus 10 over 26i. So simplify, divide by 2, 12 over 13 plus 5 over 13i. Complex solutions of quadratic equations. So quadratic equations, sometimes they have non-real solutions. So let's clarify some notation first. Square root of negative 3 is not real number. We can write it down as 3 times negative 1, which is square root of 3 times square root of negative 1. And we introduce square root of negative 1 as our new unit I, so root 3i. So in general, square root of negative a is equal to square root of a times I. So we're going to use this form, and we're using, this is the principal square root of negative I. Example, if I have square root of negative 3 times square root of negative 12. So we're multiplying two complex numbers, but in a different form. So there is no I here. I'm going to use the formula above, where square root of negative 3 is square root of 3i, and square root of negative 12 is square root of 12i. Note that we cannot multiply them the way they're given, because these are not real numbers, so we cannot just multiply the square roots. Now we can, so square root of 3 times square root of 12 is square root of 36, I squared. So that is 6, and I squared is negative 1, so it is negative 6. So another example, let's call this A. So example B, I have square root of negative 48 minus square root of negative 27. So these are not like terms, but we can simplify them. So first, 48 is 16 times 3 times negative 1, minus 27 is 9 times 3 times negative 1. So that's equal to square root of 16, square root of 3, square root of negative 1, minus square root of 9, square root of 3, square root of negative 1. Now, some of those are perfect squares, so square root of 16 is 4 root 3i. We know square root of negative 1 is I, minus 3 root 3i. Now these are like terms, so 4 root 3 minus 3 root 3 is just root 3i. Part C, negative 1 plus square root of negative 3 squared. So that is the same as multiplying negative 1 plus square root of negative 3 times negative 1 plus square root of negative 3. So that is equal to, I guess the first thing I should have done is write the square root of negative 3 as square root of 3i. I can do it now. Here you go. So now we're going to FOIL. Negative 1 times negative 1 is 1, minus root 3i, minus root 3i, plus root 3 times root 3 is just 3i squared. So like terms in the middle, 2 root 3i, and that will be minus 3, because remember I squared here is negative 1. So combine like terms, negative 2 minus 2 root 3i. Another example, we're going to solve equations more in the next lesson, but really quickly, let's solve the equation x squared plus 4 equals 0, because it's a simple one. We can write x squared equals negative 4, okay? And we know negative 1 is I squared, so I can write 4i squared. So square root both sides. Let me write this again. So I have x squared equals 4i squared. I'm going to square root both sides. And when we do that, we always do plus minus. So we have x equals plus minus 2i. So two solutions, two complex solutions of the equation. And this concludes this video.